NASA's daring Parker Solar Probe spacecraft zips past the Sun again today. It will zoom close to 5 million miles from the Sun's surface. The Parker Solar Probe is ready to make its 11th close flyby of the Sun during its quest to understand how a neighboring star works. The plucky spacecraft, heavily shielded against the Sun's radiation and extreme heat, will deep to within 5.3 million miles (8.5 million kilometers) of the solar surface on Friday, February 25th. That's about 14 times closer than the orbit of Mercury, our closest planet to the Sun. The exact time of the closest approach, known as perihelion, will be 10:36 a.m. Eastern Standard Time, 15:36 GMT, according to a spokesperson at the Johns Hopkins University Applied Physics Laboratory, which oversees the mission. At closest approach, the spacecraft will be flying at about 364,660 miles per hour, 586,860 kilometers kph. Parker Solar Probe has held the speed record for fastest spacecraft since 2018, a couple of months after its launch. By the end of its mission, the spacecraft will be sent home data from within just 3.83 million miles, 6.16 million kilometers of the Sun's surface. Getting that close to the Sun will allow scientists to continue making observations about the solar environment, particularly the atmosphere, which scientists call the corona. The incredibly hot corona is millions of degrees hotter than the surface, regardless of the scale of temperature used, and it's not quite clear yet how this huge jump in temperatures happens. Parker Solar Probe launched in August 2018 to study the Sun's outer atmosphere and includes 4 different instrument suites to learn more about how the corona works and how it affects space weather near our planet. Space weather can affect our planet in numerous ways, especially when coronal mass ejections of charged particles from our Sun hit infrastructure such as power lines or satellites. These events, however, also can produce colorful displays high up in our atmosphere called auroras. While doing solar science, Parker is also performing flybys of other planets to pick up speed and to do some side science observations. An example includes visible light pictures of Venus that the probe captured, released earlier in February. Over the mission, the probe will make a total of 7 Venus flybys to use the planet's gravity to adjust course. The next such flyby will occur in August 2023. Please save the trees and nature. Please subscribe to our channel. Thank you.
We first proposed the idea of sending a spacecraft to the Sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then, in April 2021, during Parker's 8th orbit around the Sun, the spacecraft was around 20 solar radii, or 8 million miles from the Sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker entered the corona, its whisper instrument took these images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the Sun's surface. Inside the corona, the Sun's magnetic field becomes much stronger. Solar material is slower and tethered to the Sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind, where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the Sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the Sun. Here we see distinct cells. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle, though. Exactly how they form is still unknown. Over the next few years, Parker will keep looking for clues as it explores our Sun, the only star we can study up close. The Sun is also the only star known to support life, so understanding it is critical as we search for life beyond our solar system.
That will link directly into the question, are we alone in this universe? And that is one of the biggest questions for humanity to answer.